that you have one development environment covering the whole breadth of Windows, including, by the way, 64-bit. Then we dig into some essentials, what you have to take care of, what you have to work on, what is the choices that you have to make, and they're very dynamic in game development. You will see some things there. Performance tuning, as always in games, performance is everything, and you will find out that it's not exact everything. There's another thing that you have to be very aware of, and I will go into that very soon. Then installation, you're writing games. Games are targeted at mainstream users. People that just download the game, they want not to hassle with installation, they just install it and it should run. So installation should not be a really afterthought, although it can be in the mobile space more than it is on the desktop. And then I give you a couple of pointers what you can do to enhance your games, which are not traditionally done before Compact Framework hit. So Compact Framework has a lot of functionality inside that allows you to write compelling games with multiplayers, with online facilities, content download. We'll go into that a little bit. And then at the end, I hope I have some time for Q&A. The whole session was planned for 2 hours, so I had to shrink it in 1 hour. And I hope I'm not pacing too fast. If anybody has questions in between, just fire. I hope I see all the hands because I'm blinded by the light. Okay. Essentials to a game. What does a game need? It's graphics, it needs sound, it needs fast user input, so you don't expect to press a button and then a second later the ship moves to the right or something like that. And most of all, which is the most important point of all games, is motivation. How to motivate a user to play the game again, again, again. It's not frustrated and basically tells his friend this game sucks, don't buy it. So you want to have that word of mouth promotion, and that comes through motivation. And then what else? These are the out-of-the-box things, or the think outside the button areas. You can do online score tables, multiplayers via the internet. You can have downloadable content, very famous these days on Xbox Live. And then, of course, easy installation to get the gamers started. And that already is very important for demo versions and beta versions, that if you want to run trials, that they are also going very smoothly. I constantly hit the wrong button here. So, does Compact Framework work for games? A lot of you might be skeptical about that because it's an integrated layer on top of an OS. It has to JIT all the methods that are coming before they get executed. So will that work for games? And I just checked on the three main principles first to see if they are there. And graphics is definitely there in many forms. GDI calls are relatively fast on the Pocket PC and smartphone because the screen size is very small. So even if you do large memory manipulation in the background buffer or something like that, you're still fast enough to do GDI because the screen size is relatively small. This changes now because the screen size get larger, there's more resolution coming, more colors coming. So Game API gives you even director access to the screen buffers and some other very nice enhancement functions that you can use. There is a wrapper being written right now for Compact Framework, and I was hoping I get the URL before this talk, but if you have downloaded the slide deck already, you'll find that in the notes there's a little placeholder for the URL. I don't have that yet. So as soon as I have that, I'm sure Microsoft will have a way to make that available through MSDN or even on the Pocket PC developer side. Also something very exciting, Microsoft is working on the next version of Compact Framework. You might have heard briefs and glimpses about that, and the most important for game is they actually will have mobile Direct 3D support, which is a subset of the desktop managed version of Direct 3D. Very exciting stuff, and we're looking very much forward to that, especially if you look at the newer Pocket PCs, they have already graphics and 3D accelerators as chips inside. And mobile Direct 3D will work in software for the lame chips, and it also will work fully hardware accelerated for the cool chips. So we're looking very much forward to see that coming in the future. Sound, well, I made a sort of smiley face there. The story with sound is not too great. You saw the demo maybe yesterday in the Midnight Madness from Jeff, who played this this blackjack game. And this was more or less using p-invoke to play sound. So you can already get some effects out of that if you're willing to have synchronous sound and no overlapping sound, no mixing going on, just playing back wave files. If you need more like sophisticated sound, you want to play music in the background, you have to go and look at the wave-out Weber class that actually was inside the netcf.org library that you saw just an hour ago, in case you have seen that session. The story for 2.0 netcf doesn't look much better. They have no concrete plans for sound yet, so it might be up to a cool ISV to build a nice sound library that lets you play back MP3s or something. All MP3 playback is currently done through the media player, and there's not really a good API, if at all, to use the media player even for the background sound. Now, the other thing about sound is, and that has to do with user studies, is that most of the people, they start playing the game with sound, and at some point in time, they turn it off anyway. But for the game developer, it's like this check mark that you have to have, otherwise your sound will not be sold at all. Fast input. Most games need one pad that you can work with, like a Nintendo pad, and 2 buttons for maybe firing. And all these things are there on the smartphone and on the Pocket PC. The important takeaway from this is don't assume that all devices have touch. You saw the smartphones, they don't support touch. There are other devices that might not have a touch screen. So don't focus all your attention, even if you have a puzzle game in the going or a game that really works well with a stylus. Don't assume that. Find a way to use the keyboard and the mouse to keep the pads and the hard buttons to modify and run your game. On the smartphone, the number keys are the number one input criteria, and I will get to that later. Again, wrong button. What else? Score tables, very easy to do with web services these days. So post your scores on a web server to have other players look at the scores. This helps a lot with motivation. You can see how people try to hold the top 10 position at like Gotham Racing in Xbox and how many players are actually playing. The more you have in your score table, the more you see how players are using the game. And it's a motivation for them to play it again. Multiplayer via the internet. There are like chess games that can even work with SMS. You make a move, it sends it by SMS to the next device. The next device is that player's turn, it sends an SMS back. That's one way. The other way are using, of course, the WinSock classes that are in the framework, or even do web services and have a smart proxy server in the middle between all your players that manages the game state. There is a technology called Direct Play, which is currently not wrapped for Compact Framework. It's only available for managed. And I actually have no idea if Microsoft has plans for that in version 2 to wrap it also in managed classes. Especially since it's already there, it would be an easy going. And again, it's a call to you guys. If you find some way to make a wrapper class for the Direct Play APIs, do so and make it available either netcf.org or in the newsgroups. Content download, the easiest of all things. You have a web service that hosts all the new content. The application will check live if there new content, offer it to the user. The user clicks OK and it gets downloaded. Especially interesting is that for the wireless providers like a Verizon, a Sprint, or anybody else. They want to drive their data usage on their networks, and if you have like a 500 kilobyte large levels file system, or you have background images they want to download, this is very nice, very good for the operators. They like to see that. So it's a good selling argument when you go to market with your little app. Easy installation, again, I brought that up. It's not really a compact framework task because there's no managed APIs whatsoever in the installation progress. But don't forget about that. It's really something you have to think somewhat late in your design process, but it's a very important part to make the whole experience for the user very well. Yeah, I hit the wrong button again. So let's go to the architecture. I'm done with the overview slides. I have also code that I can show you, and we'll dive into the more bones of game development. So the first and biggest advice I can give you is separate your game logic from the forms class. Probably most of you do that already with your enterprise apps to abstract between Pocket PC and smartphone. In the game section, I would not recommend that you do if-defs and have all the forms and everything in your game and detect it on runtime. If you have seen speeches that I gave in other conferences, I basically preach that you have one source tree and one binary that runs on all devices. With Compact Framework and and especially targeted towards games, I'd say rather keep the footprint small, because the footprint is the other hard criteria you have to think about when you're writing games for Pocket PC and smartphone. And the reason why I'm saying is the biggest deals that you can make as a mobile developer for games is to get into ROM of one of the smartphones or Pocket PC. And the requirements from the OEMs and from the network providers for games and stuff that is in ROM is very restrictive on the size of your game. So if you blow it up with too many graphics, bitmaps, uncompressed stuff, and it's suddenly a megabyte large, you will not get in ROM. You have to build up another distribution channel, which is still okay, but you lose that opportunity to get in ROM of the device. So always have the footprint in your mind when you design games as well as performance. And it's always a trade-off between footprint and performance. There's no way that you can get both, except you have a graphicless game, which I haven't seen so far. Maybe with all the speech technology, you come up with some cool speech game. There's no wizard to port forms over from Pocket PC to smartphone and back and forth. So you have to really recreate the forms on both sides. What I recommend is that you keep as less code in these forms classes as possible and just use the pure designers for building nice forms on Pocket PC and smartphone. In Whitby, there's a new, or Visual Studio 2005, there's a new feature coming called partial classes or partial types. And this helps you a lot to keep your code leaner. You can have a forms class and a partial class that holds all the event handlers and other stuff that is common between all forms on all platforms. Right now in Visual Studio 2003, you have to basically do that yourself and manage that yourself. Very important part on the very bottom is think about different screen resolution. There is a talk right after this one about how to detect screen sizes, how to manage large DPI screens, how to rebuild your forms when the user rotates the screen. You should think about these things when you're writing a game now too. In the past, that was not really necessary because you were focused on the 240 by 320 on the Pocket PC or the 176 by something on smartphone. This is all now open. It can be very different resolution types. And there are ways to detect that and then update your screen of the game either on the fly or with a little reset or something like that. More means are possible. So if you plan on supporting the desktop too, and that is this is possible, and I will show that in the architecture slide later. You should also separate the render engine from your game class. I will show how I propose this architecture should be done. It's not something you have to do, it's not mandatory, but it's a way that you can have one common design of smartphone, Pocket PC, and desktop. And on the desktop even I show you GDI, DirectDraw, and Direct 3D, all in one application, in one solution. And if you follow these guidelines, you can build that with all your games that you're writing. And also, if you do it right now for Pocket PC even, you get ready for the mobile Direct 3D that's coming with version 2. If you right now do the architecture right, you're ready for the future. Well, this is a no-brainer. I guess you want to render your stuff as fast as possible. But there are some differences in the devices. Some are running faster, some are running 206 megahertz, some are running 400 megahertz, although on the current version of mobile, Microsoft Mobile, it's not that big of a difference because all the Xscale and StrongArm devices are compiled with the same base compiler in StrongArm compatibility mode. So there's not too much speed difference, but I have found out during my testing that some devices are really faster and others are slower. And even if you have a 400 megahertz Xscale and another 400 Xscale device, the difference can be quite substantial. So what I'm showing here is a main game loop that prepares all the essentials for the game and then even makes sure that the frame rate is constant. It will never drop below that or never go higher than that, so that the user has a continuous good smooth feeling of the application of the game. And the other thing that you see here is I do a form show as the very first thing, and in this form show the only thing I'm doing is in the onload form is showing a splash screen, because depending on how much you have to do to initialize the form, how much you have to do to initialize your render engine, to load your game state, load your option state, whatever. The load process until the real game routine starts can be quite a while, and you don't want to have just a spinning arrow sitting there and the user is frustrated because nothing comes up. So if you look at all the games that are currently available on PocketC, nearly all of them have a splash screen and then saying loading on the bottom. And that's basically the way you do it in Compact Framework. The do events is necessary to show the form, actually, because show form doesn't actually show the form. It has to send the message to the paint engine saying WM paint, then it runs through the paint message, and that really paints the form. If you don't do events, the form show will not do anything for you. It will just wait until the first event is actually parsed. Then I set the tick counter from the environment.tick count is one of the few environment variables that you get from Compact Framework. And with that, I calculate in the two areas down here. Whoops. I calculate the frame rate, and if I'm faster than the frame rate, I sleep. If I'm slower than the frame rate, I rather render than wait another time. But if I'm faster than the frame rate that I'm expecting, I sleep until the frame rate sits there. I also do the do events in this loop because my frame renderer function is really the hardcore rendering function, which paints all the graphics to the double blit buffering back from the double buffer onto the front frame. And do events make sure that you can use the keyboard, the mouse, the stylus, and all these things. Hardcore developers tend to write their own low-level input method parsing system. Depending on how fast your game is, and my general opinion is that you can write fairly good set of games, except of like a Doom or a Quake, a really hardcore 3D engine with Compact Framework. And as soon as you step into this hardcore stuff, the engine normally provides you, for example, Fathammer has a great 3D engine that you can license and build your application on top of that. They provide you APIs to get the input and all these things with them. But they're not managed yet. You would have to go back to native development. And if you stay in Compact Framework, you should basically also obey the rules of Compact Framework, not to mess up things that might going on in the background. Other things that you get over do events is screen resize, again, the system events that you want to listen to and react correspondingly. So let me switch over to an architecture view of my game, whoopsie, that is currently shipping in a native form and that will ship in a managed form very soon. So the blue parts of that architecture are the platform-dependent classes. There's a main form where everything starts in. So you start your form, it shows the splash screen, it does the main loop, and from there all the about, high score, option pages, everything that has to do with user input in a forms way will come from the main forms class. And these two are also platform dependent. So in the solution, you will see them in each of the solution directories as separate classes. They have the same names to make it easier, but they are separate in these classes. The orange parts are common classes. They exist on desktop, on PocketC and smartphone in exactly the same form. So my solution that I show you in a couple of seconds, they're actually just linked from the desktop class. And I have very, very little defines inside where I blend out things that, for example, PocketC can't do or doesn't work on 64-bit or don't work on 32-bit. And then I have a exchangeable render engine that I can flag that with a define in the project saying I want direct 3D, I want GDI, I want game API, I want direct draw. It compiles then the corresponding engine into the system. You can also have a loadable assembly that holds these engines, parse basically what is the capability of the device, and load the corresponding engine to get the highest effects. And engine have some settings, like on the desktop, where's the window, what is my preferred resolution when I go full screen, stuff like that. And they're not necessarily the same options for the GDI stuff, but you can still put them in the same render option XML file. Also, the level design is something I decided to put between the render engine and the main class, because sometimes it depends on the level design, what you actually render on the screen. And the game state is very important for PocketPC and smartphone logo certification. Logo certification says if the device is reset or if the device is turned off, if another application comes in the front and the device runs out of memory, you might get a WM close in the middle of the game. So meaning you have to close your application. What you do is you store your game state, and when the user calls back your application by tapping on the PocketPC link, on the game link, it loads the state and continues where it was uninterrupted. Same thing is true for any enterprise application that you're building, so you should be familiar with that concept already. The game options, like how many players, what is your player name, any high score stuff, is directly related to the game code, so it gets stored by the game code class. So this is the architecture I decided, and I show you how this looks in the solution tree. If my mouse starts to respond here. You see, this is the solution directory for the desktop application. I have subdirectories for my render engines, GDI Plus, Direct Draw, and Direct 3D. And then I can toggle the render engine in the configuration parameters, which one I want to include. I have not decided to go with a loadable engine concept yet, but that might be something I will do in the future to dynamically load a Direct Draw versus a Direct 3D one. So right now it's set for Direct Draw. And if I start that, we'll compile the app and start it up as a Direct Draw application. And this is basically a puzzle game looks very similar to Mahjong, but has a different style of layout. And this little button here would go out to my web service server, register my device as a new device, and then from that moment on I can track my scores on my website to see what my high scores are. And it's a one-click web service that registers the device. And that's basically the whole game. So you have certain layouts. You have to remove the tiles, fairly basic. Now this is the Direct Draw version. You see I have a couple of animations going on, and if I find some stones that are the same, like these two, they do something until they disappear. So let's kill the game. Basically, I'd stop the game. Now I can set the flag to Direct 3D. 3D. Recompile the game. And now it will, since I saved the state of the game, it will bring up the same layout, what I did before I closed the game. But now the whole game is in 3D, using the 3D render engine. The game logic was not touched at all. And this game grabs a random picture from my picture folder and uses that as a background. And now you see it's using the 3D gaming environment that's managed. I haven't done much tuning on that yet. That's purely the first shot at 3D, looking at the whole game and doing fancy things with it. My goals for this game is basically that the whole thing rotates and does something to it while you're playing to put more excitement in the game. But it still has all the gaming rules, and everything that is in the game class is encapsulated from the render class and the forms class. You see the about box, the high score box, and the option box are basically optimized for the desktop. They look very similar on PocketPC and smartphone to have easy transitions for the users to play on smartphone, PocketPC, and on the desktop, but their layout is completely different. So if I close that game again, it will save its state again. Once you reload it, you can continue playing from exactly the point where you have left over. Now, if you look on the solution tree, you see I chose subdirectories for the render engine. This is just for organizing it better. It doesn't have any architectural value to it. The tricky part is really on top of these classes. I have an if-def on which of these three compiler switches I'm actually using. GDI Plus class is the same class I'm actually using on the PocketPC, unchanged. So it's the same class file that I'm using on PocketPC. Now, PocketJong is the Pocket PC version of that. And you see the dialogues subdirectory. You see it here. These are all my desktop dialogues. And here are all my Pocket PC dialogues. And they're optimized now for Pocket PC. I'm using inherited dialogues. I have a base dialog that does all the branding and the sizing and all the base parameters of my system. I can show you that in the designer. So all my dialogues follow this basic theme, that they have all the same look and feel when the user looks at it. And all the other dialogues I inherited from this project. You see, well, the high school dialog is not a very great example. Let's take the options dialog. You see all these linked buttons are from the master dialog, from the base dialog, and all the ones that have no links are the ones that are really in this form. Now, Pocket PC and smartphone designers don't support that yet, but it works. So you can do it if you create your form like one time from scratch and then define a base dialog, remove all the base items, and just use the init components method that creates all the dialogues manually. Then you can just nicely work with inherited dialogues. The designer's not doing that. Visual Studio 2005 and even the version that you have right now in your bag is actually supporting that too. So you can have the same concept of branding your base dialog and then adding whatever every dialog's need to it. So as I said, I linked all these files over to my master application. You see that little arrow next to the class. It points basically up to this base class that I have on the desktop. So none of these classes are physically existing. It just links up to the main class. Visual Studio 2003 has some IntelliType issues with that. My current master project is supposed to be my desktop application, but it didn't get that very well. It says I'm working on a Pocket PC app. So this is the only drawback if you're working right now with Visual Studio 2003, that the IntelliType functions will not work as you might expect if you have a mixture between a desktop app and a Pocket PC app. But to show you that it's exactly the same thing, I can put in a bug in the, let's say, in the base class. This is another thing. If I double-click in the base class and have it open with the Pocket PC class, although it's the same file, it says I have it open in another editor, which is the editor itself. So very weird. So if I put a bug in here, recompile my desktop, it will tell me there is no bug. Ooh. Oh, yeah, well, yeah. This is actually legal. Let's put some other problem in here. Well, now it should complain. Still doesn't complain. Yeah, it is the same base class. It should compile and it should complain. That's interesting. So it's smarter than I thought. It has artificial intelligence to fix that. I know this method is actually not used. I picked a bad message. Let's use a different class. The CLabs base class is something where I also have source code from OpenNetCF inside that I extracted and used in my form more streamlined, that I don't have to include the whole library. So, but I'm not using that on the desktop. On the desktop, I have I'm using the native classes that are available. So let's put something in here. That's the main game class now that I have open. So if I compile the desktop application, it should now say, well, there's something wrong here. And if I go down to my Pocket PC app, compile that, since it points to the same file, it also complains about the same bug. So if I fix it and recompile my Pocket application. Now, here's another thing. If you work with a solution that has a combination of desktop and Pocket PC smartphone, don't use that run button ever. It just picks by random whatever it likes to pick and starts it. It's very weird. So my way of doing that is really right-click the project that you want to start, hit debug, and then there's the same button there, but it's better hooked up to what exactly you want to do. The deployment dialog comes up. I'm choosing the 2003 Pocket PC, which I have preloaded. It deploys the application down. It also checks if NetCF is there. All the things that you're used to in the enterprise environment is there for game development too. Now, once the debugger is hooked up and everything is ready, my flash screen comes up. Now the loading, it's basically loading game state. It loads the option stage, and it also loads the level information if there are any. And then once that is done, it basically says, okay, now I'm ready, you can play. It took so long because I'm using the XML DOM to read my files. The DOM is way slower than an XML reader. So my next step of optimizing that game is actually using XML reader instead of the DOM to parse my session state and my game options. Now, if you say new game, you will find the same dialog that I had on the desktop. I have the button again, this time nicely designed for the Pocket PC. It is connected to the internet, registered now the emulator as a new device in my scoring system, and from that moment on, I can track my scores online. Actually, it should give me a better name than just my name. Let's keep the M in front, but you see that this is the instance I'm playing with right now when I look at the score table later. And the game starts, and it looks very familiar, very the same. And on the emulator, I don't have a background picture, so it's just black. But I can make some points here. Just remove some things. And to show you that the game state and all these things work too, I can exit that application. By the way, the exit button is just there for debug purposes. Another logo requirement for getting into all these cool programs that I'm talking about later. And if I restart the application, you will see it will pick up exactly in the same place where I left off. And since I included the same code also on the desktop, the same thing works immediately also on the desktop. Some things in game development are really driven by the Pocket PC and the mobile development. Other things are driven by the desktop development. When I wrote the architecture for Pocket Young, I started on the desktop and then basically ported it down to NetSafe. And it took me about 2 days to do that from the desktop app. But I was consciously aware that I'm doing that at some point in time. So when I did my architecture on the desktop, I already had the Pocket PC in mind. So it's loading the XML again, and then starts the game, and you see the holes where I already put out games. Now, the option dialog does the content download. So if you start the option dialog, and I will talk about forms and performance improvements later. There's no service pack installed on that thing yet. You see here in the select tile box, there's one default tile set. That's actually what ships with the game. But now there's an asynchronous web service going out to my server looking for new content. And if it finds new content, it puts that down here in the dialog. And you see, oh, there's a new stone set there that I can download. And if I select that and say, OK, now comes the friendly reminder. If you do that, it can take a while because it's going over the web. And depending if you have a GPRS, CDMA, Wi-Fi, or whatever connection you have, and depending how large that file is, it can take a while. So if I say yes, since we're Wi-Fi connected, or actually LAN connected, it should go fairly fast. It's downloading, doesn't give me any prompts. I cannot disturb that process. If I would switch off right now, it would not hurt the game. It would not continue downloading it, but it would go back to the default home screen. So fairly simple logic to not get disturbed. This is a synchronous web service call that downloads actually the content. I use asynchronous only for things where I'm not sure if the user's connected. The other thing is, if I would not have been connected to the internet, the asynchronous web service would not even be called. The Pocket PC is able to initiate connections on the first web service URL that you put in. And the Pocket PC starts and tries to connect to the internet. And that can be pretty annoying if you're in the middle of a game and you don't want to connect to the internet, and constantly this notification bubble comes down and says, well, I'm trying to connect to the internet, and you constantly have to hit disable. So my decision was, I probe, am I connected to the internet? If not, don't try even to connect to the internet. Don't do score posting, do everything in offline mode. So now I have loaded this new stone set, I can end my game. And the other thing the end game does, it posts the score to the online site. So these are my local high scores in case I'm not connected to the internet. And my online high scores. You see I scored 30 points and I'm in rank 6. There are a couple other guys that have played with their date. And you can now go to the website and actually look at that too. Actually, we can do that too. It's very nicely connected here. This site is currently not really published because it's still in beta test. But if you look here at the high score, you will see my name there. That's the one that I just did. And since it's a Pocket PC, smartphone, and desktop game, you see all the scores from all these games together, but you can say, I only want to see the Pocket PC scores. And then it shows me nothing. Because I hit the smartphone thing, here are the Pocket PC scores. That's not me. Oh, I know. Yeah, another thing that I built in. If I'm debugging, I post to a different server than if I'm having my production version out. So it basically tells the server right now I'm in debug mode to post me in a different section. Because I do so much debugging, the score would be filled with my postings all the time. But the application itself, it shows the right debugging score table. So fairly simple stuff. With Compact Framework, it's not much work, and I can show you the code if you want to, but I have to rush through my slides, otherwise we get stuck in the middle. So let me go back to the slides. Now we get back to the Pocket Chunk a little bit later. Oh, this time I hit the right button. Yay. Digging into essentials, graphics with NetCF. I said that earlier, GDI is fast enough for many games. If you're doing a 3D engine, you will say that's not true. But if you do puzzle games, if you do board games, if you do action games that have, for example, screen scrolling and like jump and jack games, NetCF and GDI is really fast enough on the current devices. Double buffering is essential. If you don't do double buffering, you get flickering on the screen, and you also lose a lot of performance. If you directly blit to the screen, it's about 30% slower than if you do everything in the background and then do a full blit of that background buffer over to the front. There are very good articles on MSDN how to do that, so I don't want to get too much into code. I have code snippets of all these things in the notes section. So if you download the slides, you will see a couple of code sections on how to do these things. Another thing that I recommend, avoid on the back buffer, it should have exactly the same size as the screen. Don't do a stretch or a shrink when you do back buffer blitting. Also, if you load bitmaps that, for example, are your sprites for the enemy ships or for whatever, try to pre-shrink and stretch them in the same size as you blit them later into the double buffer. You win a lot of performance doing that. But on the other side, of course, you lose footprint. Every time you do a duplicate of a bitmap, well, you have to 2 times in RAM. So always think about the right balance. If GDI comes too slow for your game, I said I use the game API wrapper that is coming, or soon to be there. It gives you direct access to the screen, and it will accelerate that. It's basically the difference on the desktop between GDI and Direct Draw. And this difference is dramatic. If I recompile my game with GDI, you basically will not like to play that thing. And with Direct Draw, it's very nice. On the Pocket PC, GDI is fast enough, so I don't even have to implement a game API render engine. I could. My architecture allows me just to add that, and I'm done very quickly. Most Direct 3D engines that you can license, like FatHammer, are using game API already, or even something more low level. If you then try to access game API and use a 3D engine, you will get in conflict. So you have to be aware of when you license a 3D engine that they might already block the graphics port and focus really on your game logic. Coming in Compact Framework version 2, managed Direct 3D. What you saw on the desktop side, my 3D version is completely managed. There was not one single line of code going directly to a Win32 API. And exactly that same API or same managed class will come to the Pocket PC and will allow you even easier to transit your games from the desktop to the Pocket PC back and forth. And the current plan, as you know, Microsoft has always these current plans, and then reliability kicks in somewhat later, is that it ships with Visual Studio 2005. The bits that you have currently do not have mobile Direct 3D inside. There is NetCF 2 on these bits, but it's not, doesn't have mobile Direct 3D yet. So don't think because it's not in this alpha that you have, it's not coming up. More tips on graphics. I told you about footprint earlier. In the native app space, when you did a resource, it was always stored in your application as a bitmap, uncompressed bitmap. It took up a lot of space. Now with managed code, you can use JPEGs, GIFs, or PNG files as well, and they're way, way smaller. So, for example, the background for my Pocket Chunk game this little graphics here would be about 80 kilobytes in a bitmap, and it's only like 4 kilobytes as a JPEG file. And I store that in my application, making it really, really small and very attractive for the OEMs to put in ROM. If you do work with bitmaps or resources, there's very easy way to integrate them, and there's very easy way to call them as a resource that you can put them into your application. And I'm going to skip now exactly how to do that, because most of you more likely are familiar with how resources are managed in Visual Studio. The sources will, my slides will have also loading function code that you can use to load an embedded resource and use it anywhere you want, including as a sound file or as a graphics. Yeah, I could do the demo. Let me skip ahead, and if we have time at the end, I will show you. I'll show you that. It's more how to use Visual Studio Net than really game development. Sound with NetCF. As I said, this is the weak point of like the whole story at the moment. The easiest way, and even Pocketjong, board games, puzzle games, all these have no problems with that. You can use Play Sound APIs that are on Pocket PC and smartphone. It's very simple to write a little wrapper class that calls into that. So this is all you have to do to get a managed version of a Play Sound function that Microsoft hasn't done yet in version 1 of NetCF. You can also load sound files or wave files from a resource in your application and use not the there's a flag where you can say, do I want to use it from disk or do I want to use it from RAM? And it's very, very easy to load a resource that's in your application and play it back through this little wrapper class. The node section will have the code for that. Input methods. Touchscreen is good. So when your game can use touch, you should use touch, because it's really easier for the user to grab the game concept. It's really nice to navigate. It's really intuitive what the gamer wants. But there are devices that don't have it. So you also have to think about a secondary input method, which is keyboard well, keyboard is relatively new. It's just a couple devices have keyboard, but the thumb pad is a requirement for the Pocket PC OEMs. They have to have the thumb pad on the Pocket PC and on the smartphone, so you can be sure it is there. So there's a way that cursor navigate. And also a hard-coded button. There's on Pocket PC is a requirement to have those 4 buttons that you see on all Pocket PCs, and on smartphone, these 2 soft keys under the screen. They're also mandatory. They cannot be decided not to use from the OEM. The OEM has to bring up these 2 buttons, so you can be sure that these things will be there. On the Pocket PC, the hard buttons are normally coded with like contacts, tasks, and other things. I recommend that you do not use them for your game if you don't have to, because the user normally is in the middle of a game, he gets a call in, and he has to look up a contact, and he hits the contact button, and it doesn't do anything except do something in the game, and then he gets confused. He has to basically bring back the start screen, and in a situation where you get a call and you have to maybe juggle 2 devices, it's not a good thing. So if you don't have to use the hard-coded button, try to avoid them. And also, if you take them over and you don't release them correctly, for example, your application crashes or your app crashes and the buttons are still assigned to game functions, it might lead to a problem that you really have to reset the device to get the function back. On smartphone, you can use the number buttons as cursor keys. It's actually, on some smartphones, easier to use the number buttons than the thumb pad. The thumb pad is sometimes so small and not so precise that you need for game playing. And with the number buttons, they're further apart. You can really do 2-handed game playing on a little smartphone. Soft key are normally predefined as OK and enter for the left one and cancel or menu on the right one. Don't break that paradigm. It's one of those usability things that Microsoft enforced on the OEMs and the ISVs, that they always know with the left one I can activate something, with the right one I get more options, or I can cancel out of something. And the sum part is exactly working the same as on PocketPC. So this is the one common denominator between PocketPC smartphone and theoretically the PC if you have one of those IBM ThinkPads with a little thumb thing. It works exactly the same way. Performance tuning, very important, and always good performant application has larger footprint than a not so good performant application. And you have to balance that slider, what you want, more performance or smaller footprint. There are a couple of things that Compact Framework 1 doesn't do very well, and one of those is form rendering. You saw my option page, how long it took to paint all these things. And this form is already pretty much optimized of what I'm doing. So there are a couple of things that you can do. In general, reduce the amount of method calls. It makes your application faster. So it's a bit counterproductive to the idea I have small method calls and lots of them for good structure. In the gaming world, you'd rather have large methods because they get chitted on call. So the program counter of NetCF comes to the method, it pre-chits all the whole method and then executes it. If you have a large method, it pre-chits the whole large method, and if you do a lot in this method, it's faster than if you have a smaller method and you have to chip all the little jumps to other methods. So even if you learn in school and everywhere, have good structured class hierarchies and a lot of methods, and if it's more than 10 lines, make another method. In gaming, I would rather recommend you, especially in Compact Framework, to not do that. Build larger methods, do what you have to do in this method, and then only get out of the message if you have to. And in the forms optimization, that basically means the default designer creates a size and a position property for a form or for a control. That's 2 calls into 2 different methods on the base class. If you combine that and use the bounds, it's 1 call. It's a bit larger because it takes basically a rectangle instead of 2 parameters, but it's faster. And that doesn't even have footprint implications. Also, they do something funny with their whatever master control dot controls dot add and then this pointer for the control. It does exactly the same as the parent control dot is equal to this. And this is much faster than using the forum dot controls dot add method call. Microsoft is going to fix that, and maybe they have even done that in Service Pack 2 to be in parity with that call. But right now, if you have a NetCF 1.0 app and you want to get performance out of forms, just do control.parent equals this instead of, and control would be like a button or a list box or something like that. And this is the hosting control. The other thing that's very interesting is the designer, if you look at how it builds initialized components, starts from the bottom and paints the controls up to the top. It's actually slower than if you build them from the top to the bottom. So if you rearrange your controls in the initialized components class to be rendered from top to bottom, you again win some performance out of your control rendering. This is all being addressed in version 2 of Compact Framework. They got so much heat from the developers that they tuned a lot in their in their forms engine in version 2. For smartphone, there are a couple other things that might give you headaches. The biggest thing is that these dialogues don't have autoscroll. If you're used to developing native apps on smartphone and you create a dialogue and the dialogue is longer than the screen, in the native app, you just set a flag in the resource, say it's auto-scrollable, and then a little scroll bar appears to the right, and you can scroll the whole thing. On Compact Framework, that was sort of forgotten. So if you build a large dialog form, then what's happening is you never see the controls that are on the bottom of the form. I can show you again on my application how I circumvented that by using, again, some help class from netcf.org, open netcf.org, should think about this, open in the front. So my option dialog that you saw already earlier has too many options for the smartphone to be on one screen. So at some point in time, you have to scroll down and see the other options. And it's again the same solution, same base class files, just the render engine, and the same render engine in this case, but different forms engine. Game, options. And this is Smartphone 2003 emulator. The 2002 emulator, I don't think does Compact Framework. Also here, I have the same thing with the web service check if there's a new tile set available for my game. And then you see, as soon as I hit on a certain control in a certain area, I scroll the form automatically down to the next page. It's using the onFocus event, and then I do some processing on which control had the focus before the current one, and then I decide is the user going down or is the user going up, and flip the scroll manually the form by using set Windows pause. That set Windows pause is not in Compact Framework, so I had to call that through a Weber class basically that went into native code and did the form.scroll. Form.scroll, I think. So if you're interested in that code, I can show it later again once we're done with the slides. And another thing you have to be aware of, smartphone doesn't have buttons in dialogues. Very strange thing, and I thought I did something wrong when I did that, because I had no idea what's the reason behind that. And the main reason I was explained to was that there are these two hard buttons on the bottom of each of the screen that you should use for OK and cancel. So if you have buttons in your dialogue more than OK and cancel, you have to come up with creative ways to get an on-click event on a control. In my case, I use a checkbox. If you hover over the checkbox and hit the enter button or the select button, it basically gets the on-click event, and I can do whatever I want. Switch to another form, or in my case, activate the score posting. The right soft key can hold a menu, but only if you use form.show. If you use form.show dialog, which is normally a modal dialog, everything in the background stops. The message queue only from the dialog will be used, and then once you OK that form and end that form, it goes back to the main code. If you use that, the right button is as well only a hard button. It cannot host a menu anymore. And there's no warning, there's no compiler error that tells you about that. If you just do it, it would just fail, and you wonder why my menu is not there. So form.show dialog, you have two buttons on the bottom of the form. If you use form.show, you can put again a menu on it. So I can show you how that looks like. Here you see my save and my cancel button. I cannot put a menu on the cancel button. But here, that's form.show, I can put a cascading menu there to do extra options. So if you have an option dialog or any dialog that needs more selections to do things, you cannot use form.show dialog. So keep in mind that form.show is non-modal, so the background queue will still be worked at. So if you have a game loop, the game will continue to run. So you have to build up your own pause mode in the background to be sure, I'm in form right now, I want to pause the game in the background. You do your forms operation, you go out of the form, and then you unpause your game in the back. With a modal form, you don't have to do that. It's done for you automatically. Save your game state. I said that earlier. For logo compliance, you have to think about that fairly early. So think about what state of the game you need to persist. And in my case, I use an XML class that I just serialize down to the flash. And you might ask, how do I do that? Because there's no serializer in NetCF. Well, you have to write your own. And I'm preparing an article for MSTN that shows how to do that. Currently, I get some resistance from Microsoft because I'm not really serializing in the .NET sense. I'm basically storing my class data to disk, which is the long explanation for serializing. But since I'm not following all the serializing rules that Microsoft set up for the big framework, there's a hiccup on this word serializer. I'm using code reflection to just parse what fields are in the class. And I dump them as XML in a file. So it's fairly generic. You can use that with any class that you have. And it makes life a lot easier than not having a serializer and build your own structures and somehow save them to disk. Don't use data sets, by the way. Data sets in games are footprint killers. If you try and create like a 500 megabyte large data set, it will eat up about 5 to 6 megabyte in RAM. And the larger your core data in the data set will be, the larger the RAM usage of that thing will be. And it really kills your footprint very quickly. Data sets I started with because they have this nice save as XML method. Just say, well, dump everything in a data set and call save.xml. That would have been nice, but data sets are not really optimized for game state saving. The other thing, of course, SQL Server for game state, it's a little bit overcast, I would say. So if there's a SQL Server on the device, you can use it, but you cannot bet on that yet. So that's why I basically go with raw XML, storing it and loading it with my own class. Installation. I keep it very brief, though it's a very important issue. On the mobile space, it can be an afterthought. On the desktop space, I would start thinking about installation a little bit earlier. Also, if you have dependency that you have to store. There's a very good article on MSDN that explains how you build an MSI file that detects is Compact Framework on the device, and if not, installs it on the device. One side effect of having to deal with devices like PocketC 2002 that support Compact Framework but doesn't have it in ROM is that you have to really look, is all your stuff there before you install your game. In the native world, you didn't have that problem. But now with Compact Framework, you have to look, is Compact Framework there? Is the service pack right that's on the device that you require? And if not, you have to install it. Now, in my case, my game is about 200 kilobytes, and I have to tag along 2.5 megabyte for the Compact Framework runtime and another megabyte for the service pack 2. And for downloaded up that it's only 200 kilobytes, it's a bit not so good. So this article goes into a point where you can basically download the cap file from the internet and then stream it on the device if it's not there. If it's already on the device, you have a little MSI file and your game, keeping the installer very streamlined. Another recommendation I have for you, keep the installation as low verbose as possible. I've seen like installer that greet you, then ask you for a path, then ask you for user information, and then say, thank you, now we're installing. Then comes the installing. At the end, thank you, I did install everything that you told me to. So you have like 5 dialogues, but the users normally click OK, quick, and it's done with it. Never reads any line. If you have really a game, the only extra dialogue that from a greeting dialogue, process bar, and thank you page might be a serial number that you have to type in. But keep it as simple as possible. Have an introduction screen, ask for the serial number on the introduction screen, show the process, how your stuff is being installed, and then say, okay, I'm done, everything worked out, great, go away. Don't blow up the installation. That's, by the way, something I would also like to see in enterprise apps, but they sometimes need more customization, and yeah. On the ActiveSync side, installation has become a bit easier with Visual Studio 2003. It's not super great yet, but it's at least giving you a starting point. There's a cap wizard in Visual Studio.net that allows you to easily build a cap file from your project. In my case here, I can basically right-click. Oh, I'm still in debug mode. I have to go out of debug mode. Right-click, build cap file, and it detects all the files that are not in resources, builds everything together, and builds my cap files. And at the end, I have a nice little inf file that I can reuse, and I have a nice little cap file that I can start with. And I say start with because you have to do some modifications. You're in the game world. You don't install your application under start menu programs. You want to have it on the start menu programs games. And for that, you have to modify the information file, the inf file that defines where it gets installed. So in this case, PocketJong, see cups, debug. This is what you get out of it. And actually, after you hit the cup wizard, it's under objects, debug. There you find everything the cup wizard does. And there's the inf file. You can copy that somewhere else, modify it, and work from there. In the past, you had to even think about the basics yourself and create an inf file from scratch. Now, Visual Studio 2003 gives you at least some help in doing that. In the bits that you have from Visual 2005, there might be even more inside. They have very good plans for a deployment tool that works similar to the desktop, where you can set register keys, you can define where the shortcut goes, which icon to be used for the shortcut and stuff like that. So it makes things easier. And in my slide deck, I show you where the location of the in file is, and also there's a batch file that compiles that. And if you save that in a safe location, you can start working for it. And the first thing you have to do is change the game location from program files to CE14, which is a macro pointing at the game's location. So now when I showed you pocketing, a couple of things that I think games of this modern age have to have, and Compact Framework has a lot of support for that. And web services, I can't stress that enough, is a very, very simple way to get these things done. Gaming is all about motivation. If you don't get your player to play again, they basically delete it from the device, and they don't spread the word it's a good game, and nobody else buys it from the friendship area. So you want to win that word of mouth marketing, I always say. And so you have to find ways to attract the player to play again. And one of the things I found is score posting is very, very interesting now with the Xbox Live system, where people look at other people's scores and they define friends. They only look at the friend scores. And then if one friend got better, well, they go back and play the game again. And this is all about motivation to play the game again. Content download is another very cool thing to keep the game up in the mind of the player. He reloads the game, he replays it. Oh, well, I'm bored with that. Let's see if there's no content. Oh, yeah, there's new content, new background pictures, no tile setup in my case, new sounds, whatever is there to make the game more attractive. And that you can do on the fly. You can even charge for that theoretically. Give the game out for free and have the content be the money cow. So there are creative ways even to make money with that thing. And the other thing has to do with the online gaming. You build communities around the game and have friends playing against each other. It's also a very good way to get around the fraud problem of score posting. If you don't encrypt your posts very well, somebody could just call the web service with 1 million points or something, and it would show up in the score. But since, in my case, I'm tracking the device basically over the GUID, I know exactly which player you are, and if there's a GUID coming in that I don't know about, I don't show the score. And you can define, oh, this player I know, this player I know, I have the 3 GUIDs, and only these I show in my score table. So there are ways to get around this fraud problem by just limiting how the user sees the scores at the end. Lobby servers, another very cool thing. You want to know who's online. Actually, I think I showed you that very briefly on my site. There's this little icon here in the back. It's like a presence icon. It says, in this case, well, the player is in the middle of the game, but he turned off his device or he went away. So he's basically playing, but he's not online. And then there's a red icon for someone who's playing. There's a blue icon for somebody who's not playing, has the game running. And then you could tap on that icon and say, I want to invite this guy for a multiplayer game, and initiate basically the multiplayer game over the website. And all these things can be done with web services. There's no other technology that has to be learned than web services. And in the future, Indigo for events and a lot of fun stuff. Good. Let's go back to this guy. So, another important aspect of gaming, how to get it sold. Where can I send it to make money with it? Because everybody here is about making money. And there are a couple of distributors that have focused around mobile development. There were a couple of sessions on mobile to market, which is the Microsoft initiative to bring communities together, developers together, and help them deploy and distribute their games very easily. Requirement for mobile to market is certification. So everything you do, you have to have certification in mind. The certification criteria are written in a way that they are 60–70% are really towards enterprise application, and only 30% really applies to game developers. And when you go through certification, you can just NA the things that are not relevant for you. Then you send in the game to certification. Veritest does that. A couple other vendors that also offer certification. And then you can apply at mobile to can submit your game to mobile to market. They display that catalog to OEMs for being included in ROMs. they display it to Handango and Pocket Gear and other redistribution sites that then take up the this catalog and include it in their offerings. You can also go directly to pocketgear.com or handango.com, and I see Heather sitting here. So she is the program manager for all Pocket PC stuff at Handango. She will help you get enrolled with the Handango reselling catalog. And Handango is a good example of how catalogs are reused. Handango does the orange catalog, they do the AT&T catalog. It's all branded in the AT&T colors. So if you go in with your smartphone to an orange, to the orange application side, download side, it's basically a Handango that's in the back end. And well, you can also build your own site, which I always recommend if you have the means of doing as well. Why not? It's additional stuff. You can have beta versions on it. You can have score stuff on that, and tell more about your game. So that's not the most. It will not give you the most revenues, but it's a good thing to have in addition to all the distributors. Well, since I'm the session that is before the very last one, all these sessions are basically over yet. But you see a couple of other sessions that are going on or have been held during the week. Take the slides, look at them, especially performance tuning and the future of gaming, which I hope was going tremendously about mobile direct 3D, so that you get the whole picture on game development. The smartphone is no exception. In fact, when I submitted my PocketJump for smartphone certification and put it in the catalog, my sales went up dramatically, funnily, for the Pocket PC. But since I had it enrolled in the smartphone catalog, people got the cross-reference between the smartphone and the Pocket PC app and even bought the Pocket PC version. So, and smartphone has the potential to become way more higher numbers than Pocket PC is. It's a very good platform to run puzzle games, anything that you have to play with one hand. That's basically what you should focus on if you design it for smartphone. Well, I think you have seen this slide a couple thousand times, so please fill out your evaluation forms. If you're lucky, you win one of those cool MPX 200s. And yeah, I don't want to repeat what's on the slide. So I open it up for question and answers, or I can show you more about the architecture. But let's. .NET itself has some globalization functionality inside that you can do for resource translation. All the resources are basically held in an XML file. You can give the XML file to a translator and then bring that back in. It works in the Asian market as well, the same concept, because the XML file is just Unicode. The thing that I do not recommend is having all the languages in the same file. I rather recommend you have an English version, separate bin file for the French version, separate bin file for the Chinese version. Just again, to look at footprint. So you have to do some smarts in your architecture to compile the file multiple times, one for each language. And everything else you inherit basically by having the compact framework being hosted inside Visual Studio 2003. You get all the benefits that the desktop system has also for the device. There was a question down there. You should be aware of that, and there are notifications that you get when a phone call comes in. You can pause your game, basically. You need to handle that yourself. It's not automatically handled by the phone. If a call comes in, on Pocket PC you see the bubble with the incoming call, and then you get a notification as a game if you register for that notification. And then you can decide, oh, I want to pause the game. And if the user ends the call, you bring him back to the screen and unpause the game. It's fairly simple to do, and there are source samples on the web at MSDN that show how to do that. Yeah. Yeah, the shortcomings are mainly in the mixing part. If you have a high-paced game and you want to have like fire and explosion at the same time occurring, you cannot do that with sound play sound. It always plays the last sound that was initiated. And there are certain flags that you can set that gives you a little bit of freedom, which basically if you hit fire and you hit the ship and it explodes, it cancels the fire sound, not even if it's played through, and starts with the explosion sound. But it still sounds ugly. In a high-paced action game, you really want to mix the sound. You want to have the fire effect and the explosion effect occur sort of simultaneously. You cannot do that with sound play sound. So if you have a board, yeah. This is the second option that I had on the screen with the wave out API. This gives you complete mixing freedom on the lower level, but you have to do a lot of code to do that. You have to basically take the two wave files, mix the stream yourself, put it in the output buffer, and trigger that. So it's way more work. And since it's not something you can just set up in a movie, now place this sound, now place that down, and then you pre-render everything. Everything has to be on the fly. You have to do a lot of work on that side. In the direct sound arena on the desktop, all this is done for you. You just say basically play, 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 and the mixer underneath just mixes it. It's under the hood is pinvoke, comes from the netcf.org OpenNetCF library that was in the speech before. There's the Soundwave API. It also has actually recording functionality as well in that class. And games not at the moment I would say use recording. I'm pretty sure that in 5-6 years all games will have interactivity through voice commands, through chatting during the game. But the devices are way too slow for that right now. And the network is too slow to transmit these things, so I think you don't have to really do the recording yet. So if you go to netcf.org and look at the library, it's full in source. You just grab the parts that you need and optimize it for your game. It's a good starting point to get all these problems going. I know from experience it's very hard to get going. Once you have solved the fundamentals, the rest is relatively easy. Read the microphone. That's exactly the same API. The wave out has also a wave in API that does the recordings. It's mainly meant for enterprise applications that want to do some recording functionality, put that into a blob in a SQL server, and then if you read the form back and somebody had a comment to one of the fields, you just play back the sound. It's not integrated in any way. It's just pure wave in stuff. You even have to do the compression yourself. There's no, as far as I know, no compression algorithm available that gives you like an MP3 at the end or a GSM something at the end. It's always native wave sound, basically DA converter that just gives you the raw bits. And then you have to do some smarts to process that. For games, it's not. I think it's too early for that. You see in the speech server side there, they're very cool in that direction, can do a lot of things, and that will all come down to the mobile devices. But yeah, we need to see a couple more zeros after the 2 before that happens. Yeah. Any other questions? Good. I think we're through. I think we have also went over. Thank you very much. Have a good show.